right, this is our final video for Unit 7. This is Lesson 5. We will be factoring polynomials. Okay, factoring polynomials. We're going to do it a couple different ways. This is only the beginning of factoring. We'll be doing more in the next unit, but I wanted to introduce it now, especially when we just multiplied polynomials. Okay, so the first thing we're going to do is we're going to look for a greatest common factor. That's what GCF is, greatest common factor. So let's review what greatest common factor is really quick. So if I have the numbers 18, 24, and let's do 30. What is the greatest common factor among those numbers? Okay, so first you have to think about what are factors. Factors are numbers that can be multiplied to get the number. So factors of 18 are 2, 3, 2, 3, and 6, and 9, right? 2, 3, 6, and 9. What are factors of 24? 2, 3, 4, 6, 8, right? And then factors of 30, 2, 3, 10, 15. So what is the greatest common factor among these three numbers? Well, actually, it's just 2, isn't it? Okay, because 4 doesn't go, oh no, it's 3. It's 3, right? So what's 18 divided by 3? 6. What's 24 divided by 3? 8. What's 30 divided by 3? 10. That's not right. The greatest common factor must have been bigger than that because I can still divide those by 2. So what did I miss? What did I say the factors were? Let me erase these. Some of y'all are probably like, duh, Miss Ray, it's this. Sorry. Okay. So the factors of 18 are 2, 3, 6. That's what I missed. 6, right? So what is 18 divided by 6? 3. What's 24 divided by 6? 4. 30 divided by 6 is 5. There we go. 3, 4, 5. Okay? So that's what greatest common factor is. Is 2 a common factor? Yes, but it's not the greatest common factor. All right? So now we're going to apply that over here. So I have 10y cubed plus 20y squared minus 5y. Now notice they all have a y. Okay, so that's probably a good clue that I can factor out a y. Now let's look at the coefficients, 10, 20, and 5. The common factor there is 5. So I'm going to factor out a 5, and I'm also going to factor out a y. So basically, I'm going to divide each of these terms by 5y. 10 divided by 5 is 2. Y cubed divided by y, remember our rules. Y cubed divided by y is y squared. 20 divided by 5 is 4. Y squared divided by y is y. Negative 5 divided by 5 is negative 1. Y divided by y is 1, so it's just negative 1. So that's how you would factor that using the greatest common factor, because each of these terms had a common factor that I could divide by and bring on the outside. This is chapter 8.2, the section 8.2. So if you need help with this, please go to 8.2 in the book. Here's another example. Negative 12x and minus 8x squared. Well, they both have an x. Okay. Now, if this had a squared, then I could factor out x squared, but it doesn't. And then negative 12 and negative 8, let's see, 4. So if I divide by 4, I'm going to get negative 3. Okay, x divided by x is 1, so I don't have an x here anymore. Minus 2x, because x squared divided by x is x. So that's how you would factor that. That's just using greatest common factor. All right, so now we're going to factor polynomials where there is not a greatest common factor. And we're going to do this right now only when the leading coefficient is a 1. So here's the standard form of a quadratic. A quadratic is when the degree is a 2, right? When the biggest exponent is a 2. So that leading coefficient is a. Okay, so when a is 1 is all we're going to worry about right now. It's pretty simple. All right, so if you remember back to our last lesson, we learned how to multiply this, right? X minus 3 times x plus 5. We learned that that's x squared plus 5x minus 3x minus 15, right? And when we simplify, these we end up adding, don't we? I don't know why I have 2 plus signs there. Let me erase that. Right? We end up adding these 2 middle terms. And how did we get the 15? We multiplied these 2, didn't we? So how did we get 5x? We multiplied. Negative 3x we multiplied. But then we added the 5 and the minus 3. Okay? So I want you to consider that as we look at this. So what we're trying to do is we're trying to take this and make it look like something like this. All right, now I could tell you to guess and check, and we could probably do that pretty easily. But I also have an easier way. So let's just for a moment guess and check. So if we have x squared, then we know that our factors are going to be x and x, because that's the only way to get x squared. Okay, so now we have to consider what these two numbers would be. Well, we know that these two numbers, they need to multiply to be 24. They have to do that. But they also have to add up to give me 10. Well, what are factors of 24? 1, 24. Does that add up to 10? No. 2, 12. Does that add up to 10? No. 3, 8. Does that add up to 10? No. 4 and 6. Does that add up to 10? Yes. So those would be my factors that would go here. Okay? And that's really all it is. Okay, and you're like, oh, that's easy. Well, it is for now. Okay? You're not going to want to guess and check every single time. So I'm going to show you an easier way. You're still sort of guessing and checking, but it's a more organized way. So follow with me. All right, so you're going to draw a little X here. And at the top of the X, you're going to put whatever A times C is, okay? Looking at this model here. And at the bottom, you're going to put whatever B is. So what is A times C in this example? Well, A is 1 and C is 24. 1 times 24 is 24. My B is 10, okay? So now I'm going to make my table, which I already did, for factors of 24. I always want things that are going to multiply to give me 24. And then from my table, I can pick which ones add up to give me 10. So that's how I get my 4 and my 6. Okay? So these are the factors. They multiply to give me this. All right, let's do another example. We're going to use this method. So what is my A times C? A times C is 1 times 12, which is 12. My B is 7. So I'm going to make a table for factors of 12. 1, 12, 2, 6, 3, 4. Now I want them to add up to be 7. Well, that's 13, that's 8, this is 7. So 3 and a 4. So my factors are going to be x plus 3 and x plus 4. Right? Easy. Now the reason those are easy is because these are all positive numbers. Okay, it's a little bit trickier when you have negative numbers. So let's take a look at that. All right, so here we have B is negative. This is our B. Our C is positive. All right, so what is A times C? It's just 16, right? 1 times 16 is 16. My B is negative 10. So my table is going to be factors of 16. 1, 16, 2, 8. That's it, isn't it? Okay. Do any of those add up to negative 10? Well, of course not. They're all positive numbers. Okay. But think about it. What is another way for me to multiply numbers to get positive 16? Couldn't I also do negative 1 times negative 16? Or negative 2 times negative 8? Isn't a negative times a negative also a positive? Yes, it is. Now, why didn't we talk about that in the last example? Well, because the middle term was positive, so it didn't matter. Okay, but when your middle term is negative, it matters. All right, so now if I add, can I get negative 10? Yes, negative 2 plus negative 8. So those are my factors that go here. So now I have x minus 2 times x minus 8, which, by the way, is the same as x minus 8 times x minus 2. Okay? And then here we have one where our C is negative. Uh-oh, what's going to happen there? So 1 times negative 18 is negative 18, and B is 7. Now, how am I going to multiply two numbers to get negative 18? Well, I have to multiply a positive times a negative. So I can multiply 1 times negative 18 or negative 1 times positive 18. Both of those are going to give me negative 18. Are they going to give me a different sum? Well, yes, they are. This one's going to be negative 17 and this one's going to be positive 17. Okay? Now I need a 7. I need a positive 7. So if I need a positive number, that probably means that my bigger number should be the positive number. So what are my other factors of 18? 2 and 9, 3 and 6. Now I know I need a negative here. Which number should be negative, the 2 and 3 or the 9 and 6? Again, if my answer is positive for the sum, then I want the bigger number to be positive. So these need to be negative. Negative 2 plus 9 is 7. Negative 3 plus 6 is 3. So I want to use -2 and +9. So my factors are going to be x minus 2 times x plus 9. Okay, and again, you can always check this, right? I can multiply this out and see if I get the correct answer. That's a great way to check yourself. All right, so let's look at this. This says when B and C are positive, the factors will be, so that's like these examples here. When B and C are both positive, our factors are also positive. The factors will be positive. When B is negative and C is positive, that's right here. When B is negative and C is positive, what happens? Both of our factors are negative. When C is negative, it could go either way. The factors will be positive and negative. That we'll have one positive and one negative. It's the only way you can multiply to get a negative number. Whereas there's two ways to multiply to get a positive number, right? I can multiply negative times a negative or a positive times a positive. All right, one last example. This is where both B and C are negative. Okay, well, what happens when C is negative? It's still the same, right? One's positive, one's negative. So draw my x. A times C. 1 times -24 is -24. My B is -5. Now, because my B is negative, that means I want my larger factor to be negative. So I need them to multiply to be 24. So I'm just going to do the numbers without the sign. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So what side should be negative? The bigger side, right? Because my answer needs to be negative. So negative, 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 negative. 1 and -24 is -23. 2 and -12 is -10. 3 and -8 is -5. Ding, ding, ding. There's our answer. This is -2. So 3 and -8. So my factors are x plus 3 and x minus 8. Super simple, right? Okay, we have to understand this super well in order to do the ones that are going to be more difficult. So the more you practice this, the better. This is section 8.3 in the book. So I would like for you to go to section, let me write this down here, 8.3 in book, and I want you to do 5 practice problems. Okay, from the from the end of the section. Okay, I don't have the page number in front of me, but go to section 8.3 in the book and do 5 practice problems from the end of that section. All right? All right, good luck, and I'll see you in class.